Hello everyone. In this video we will understand one of the important question which is present on the LeetCode, and this question is a design question. The question name is throne inheritance. So this question will test your knowledge of the application of the various data structures, whether you can apply the knowledge of the data structures or not. And this question is asked in the interview of the product-based companies. It can be asked to you also in your next interviews. So if you are preparing for the low-level design, then this question can be a starting point or a practice question to understand more about the applications of the data structures and the preparation of the low-level design. So I'll be telling you the how you can solve this question with the various approaches, and I'll also show you the or explain you the code to solve this question. Okay, as I will be explaining you all the approaches and their implementation for this question, so this video can be a bit longer, so please be patient. So without further ado, let's start. So this is the question and this is the question statement. Okay, and here it is the skeleton code for this. So we are given the class. Okay, I'm solving in the C++. You can solve in any language, and here if you see we are given this. Okay, so there are various APIs, okay, in the classes. Okay, and we have to see how we can fulfill the requirement of this question. Okay, so let's understand the question first in the simple terms. Okay, so the question says that there is a kingdom. Okay, and as usual in a kingdom there is a king and there are his children. Okay, there are many grandchildren. Okay, and there are so on. Okay, so they say ki in this kingdom someone dies and someone born also. Okay, as usual someone will be dying in the family, okay, or in the kingdom, and someone will be taking the birth, right? And then they say that let's say if king dies, okay, the current king dies, then who should be the next king? Okay, who should be declared as the new king? There is a, you can say, well defined order to tell this inheritance, that who will be inheriting the kingdom next. Okay, they say that king is the first member, that is given in the question. Okay, that king is the first member of the, you can say, kingdom. Okay, then as usual as we have discussed, that we have parent. Okay, then there are childrens, and people will be taking birth, people will be dying, right? Then they say if a person dies, okay, a person in the kingdom dies, then it will not affect the order of inheritance, or who will be the successor, that is who will be the you can say next person who will be like going to be the king. Okay, so that of the person will not affect, okay, anything in the order of inheritance. Or you can say that you can just treat that person is died. Okay, we will explain it much better, or we will understand it much better when we will be solving the question. Okay, and here you can just neglect this part. Okay, you can just neglect this part, okay, for the time being. Okay, now this is the input given in the question. Okay, this is the input. Now let's understand, but I'll tell you this input in very simple terms, and later we will understand what does this input in like in total what does it mean. Okay, so they say that king is the first member. Okay, here king is basically, you can say, the name of the king. Although it is written as king, you can take it any name. Okay, ABC, or you can say Ram is the king. Okay, Ram is the king. Okay, they have taken king only as the name also of the king. Okay, so king is the first, you can say, the person who is the current king. Okay, then they say that there is a birth in the kingdom. So when someone is taking the birth, then there will be a child and there will be a parent also. Okay, who are, you can say, going to give the birth to the parent. Okay, so they have just given the name of the parent. Okay, and then they have said who is the children. So this is parent and this is children. Okay, so this birth, okay, you can say this birth. Okay, so these are basically the function, and you can say this king and these are like the argument. Okay, in simple term. So they say ND is the children of the king. Okay, so basically king has a new children, that is ND. So king has a new children. Okay, so you can just draw like this. Okay, then there is a new birth and there is a new children Bob. Again the parent is king, so king has a new children, that is Bob. Okay, again there is a birth. Okay, and this is parent, this is child. So Catherine is the new child of the king. So we have joined Catherine to the king, right? Now they say birth again, who is taking the birth? Matthew. And who is the parent of Matthew? ND. So ND is here, so Matthew is the child of the ND. So you will be thinking why I'm drawing like this. So basically in this way we can better understand the hierarchy. Okay, so whenever we understand something in the hierarchical form, we draw in the form of like tree. Okay, we have a node, we have branches, so that's why I'm trying to build in this way the diagram. Okay, then again they say there is a birth and Bob is the, you can say, parent, Alex is the child. Then again there is a new birth and Bob is the parent and his children is Asha. Okay, so then there is a new birth, so Bob has given the birth to Asha. Okay, now here this function or this thing is saying get inheritance order. That is, it is saying if this is the current order, or you can say if this is the kingdom and here this is the order of the parent and their child. Okay, then what will be the inheritance order? Okay, so that is starting from the king, you have to tell that after king who will be the next king. Okay, and after that next king who will be the next king, and so on. Okay, so what does inheritance order means? It means, let's say someone comes to the king, okay, and he asks the king, hey king, can you tell me that who will be the going to the next king after you, and if someone also dies in the future, then who will be the next king, and so on. So that order of inheritance, he this person is going to ask to the king. So how king will be telling this order of inheritance? For this there are basically some rules. Okay, based on that this order of inheritance can be told. Okay, so according to the question, these are the in simple terms, these are the rules, okay, based on which we can tell the inheritance order. Okay, so the question says currently king is the current king. Okay, so king will be the first order. Okay, so basically this will be the output that you have to return. Okay, according to the question, so king will be the first king. Okay, who is basically the current, okay, current king. Then who will be the next king, next king, next king, you have to tell. Okay, so the question says if x has children. Here x I have considered a node, okay, or you can say a person. Okay, so if a person has children, then the next successor will be the oldest child of that person. Okay, so for example, this king is the current king. Okay, and this king has 3 children, Andy, Bob, Catherine. So who will be the going to the next king after this king, let's say, dies? Okay, let's say dies. Okay, so Andy will be the next king. Why? Because if we saw here, Andy was the first children who took the birth, then Bob came, then Catherine came. Okay, so these are the, like, Andy is the elder brother. Okay, or you can say elder sister. Okay, so this will be the person who will be the oldest, okay, in the age, so he will be the next king. Okay, so Andy. Then the question actually says that according to the rule, then again you have to go to the Andy. Okay, and you have to see down. Okay, you have to see the children of the you can say Andy. Okay, so now who will be the next king? You have to see down. So you have to see again the children of the Andy. So if this Andy, that is this X, has children, so yes, then who will be next successor? Again, oldest child of that X, that is oldest child of Andy. Andy has only one children, so Matthew will be the next king. Then now this is the X. Now this person has no children, right? So this rule will be applied. If X has no child and X is the king, okay, so this Matthew has no child and this person is king also. Okay, so that means if he is the king and there is no child, then who should be the next king? So basically we can't say null. Okay, null can be the king. Okay, it can't be. So basically we have to return. So do nothing, just return. Okay, so Matthew is already taken into account, we have to return. Okay, we return. Now after returning, who will be the next king? So the according to the question says now you have to see the next oldest child of this X, okay, that is Andy. Who is the next eldest child? Again, Andy has only one child, Matthew, who has already been taken into account, so there is no other eldest child. So it again we have reached to this thing that X has no child. Okay, and X is the king. Okay, basically we have backtracked basically to the Andy. Okay, Andy is the king and he has no other child. Then no worry, just return. Okay, then we came to the king. Now again it will be asked to the same. Okay, this is now X. Is X is having children? So X is not having any children or not? No, X is having children, Bob and Catherine. Okay, so X had children. So who will be the next king out of Bob and Catherine? Who is the oldest? Okay, who is the eldest person? So eldest children out of Bob and Catherine is Bob. How? Because in this order of sequence, who took the birth earlier, he will be the eldest person. Okay, so Bob is eldest then Catherine. So Bob will be the king according to the question. Okay, now after this Bob is the king, that is he is the next X. Okay, so it is like we are going again calling this, okay, Bob. Now again, who will be next king? Again, if this person has children, so out of this the eldest person who will be the person, he will be the children. So Alex is the eldest person. If you see here also, first Alex took the birth, then Asha came, so Alex is the eldest. Okay, now after that X is this, and he has no child, so do nothing, return. Then Bob again is the current king. Who will be the next child? Oh, sorry, next king. Again, Bob has children. Okay, and out of the leftover children, only Asha is present. So this is the only person. So this is the king. Okay, now again Asha has no children, so do nothing. Again backtrack. Okay, now Bob is like out of all the children. Okay, there is no other children left. So again we will be going back. Okay, so again we came to the king, and again we ask whether you have children. So he will say yes, I have the children. And who is the eldest? Again only one person is left, again one children is left, so Catherine is the only person. So now this will be the next king. Okay, and after Catherine is your child or king, then we'll ask Catherine, do you have any child? He will say no, so just go. Okay, now king, we will ask whether you have any other children. You will say no, so king has no child, do nothing, return. And return means the function will be over, and this is the order of inheritance. That is, at the current situation, king is the like current king, then Andy will be declared as king. After Andy, Matthew will be the children, Matthew will be the next king, then this next king, next king, next king, and next king, and so on. Okay, now this is the another input. In this input I have just added this thing. Okay, death, then again, then death, and then again you have to tell. Okay, so basically this is the same thing till this point. Okay, birth. So this will be the same order of you can say the node construction. Okay, now here they say get inheritance order, right? So basically get inheritance order means list down the order of the kings. Okay, so this is same as previous, so this list will be written as the output for this. Okay, they have said that this person, that there is a death of some person. Okay, so there will be one person who will be going to die, so they say that Bob is dying. Okay, so this null is for basically this. Okay, now who is going to die? In the input they have said Bob is dying. Okay, so Bob died. Okay, so I will just write D means that Bob has died. Okay, and then they say tell me the inheritance order. Okay, so this Bob has died. Now who will be the what will be the order of inheritance? So the question means that let's say this all these persons were alive, then after some time Bob also died. Okay, then in this case someone comes to the king and he asks, okay, what will be the order of inheritance, can you tell me? Okay, because Bob is died. Okay, Bob has died, so Bob will not be in the output list. Okay, because Bob has died. Okay, so basically this someone asked at t1 time, t1 equal to 1 p.m, so this will be the list. But what happened at t2 equal to 2 p.m, this Bob has died. Now someone came at time 3 p.m, and that person asked to the king that can you tell me the inheritance order now? So there would be new order of inheritance. So the question says that that of the person will not affect the order of inheritance. Basically how it will work, again the same rule will be applied. First king will come. Okay, king will come, then the out of all the children of the king, the oldest person will be the next king. Okay, so Andy will come. Okay, then all the children of the Andy will be taken. Okay, and according to the rule eldest person will be taken. Okay, so Matthew. Okay, then we'll go up, then up. Okay, then we will check the Bob. Now Bob has basically died. Okay, so it does not mean that this Alex, Asha, they will not be like coming in the order of inheritance. They will be coming. Okay, Bob will simply be neglected. This is meant by this line, that death of the person will not affect the order of inheritance, it will just be neglected. So you can just assume that Bob is not there, but some dummy person is there. Okay, but you will come here. Okay, you will neglect Bob. Okay, so who is the eldest person out of Alex and Asha? Alex. So okay, so Alex will come. Okay, after Matthew, then as per the rule Asha will come, and then as per the rule Catherine will come. Okay, so this note you can consider that this is there, but you will not take into account. So you can say only Bob will not be there, all the rest of the person will be there in this out. Now after this you can just ignore this, okay, this is by mistake, okay. So this will be the output, okay. I hope you have got the idea now that what is the question statements saying, and what is the input and what is the output that this question is demanding. So how you are going to solve this question, or basically to figure out that how to store the various information that is told to you in this question, which data structures basically you are going to use, like tree, map, vector, array, or something else, okay. So you can pause the video and can think first by yourself, okay. Then this will give you a clear idea, or you can say the starting point, that how you can actually solve this question. So I hope you have got some idea. So let's start. So I'll tell you the three approaches to solve this question. So first approach will use the tree data structures, okay. And second approach will also use the tree data structure. Third will only use the map, okay. It will replace the tree data structure altogether, okay. And in the approach one, along with the tree, I will be using vector, okay. Vector basically we will be using in all the three approaches, okay. And in second approach, I'll be using vector plus map also, okay. And in the third approach, along with the map, okay, I'll be using the set, okay. So let's see these approaches one by one, okay. First I'll tell you only the approach, okay, that is what does this approach actually means and how it is going to solve this question, and then we will understand all the three approaches in detail with the help of code, okay. So this is the input that I will be taking, okay, in our further discussion. So basically here I have taken that Ashok is the king, okay. So you can say Ashok is the name of the king, okay. So here you can say that Ashok is the king and Ashok has child Andy. Then next birth was there in the kingdom, and Ashok was the parent and Bob was the, you can say, his child. Again, next child was Catherine, and so on, as we have seen in our previous questions. So in this approach one, we will be using the tree data structure along with the vector. So why tree data structure? Basically, whenever there is a meaning or there is a discussion of the inheritance, then or hierarchy, then we normally think about the tree data structure, because it well define the you can say the order, or you can say the hierarchy, okay. And in this question also, the way that inheritance order is defined as per the rules, the tree data structure best suits. But let's see how, okay. So let's say this input is given. If we draw this in diagram form, okay, so this order basically is showing in the tree data structure. So see, Ashok is one node, okay. Each person is basically a node, okay. And if you see, these are three children, Andy, Bob, and Catherine. So you can say there is a vector in this node, okay, okay, in this node, and this is first child, okay. Then there is a second child and there is a third child, right? So again, in this Andy node also there will be a vector, okay, and there is only one child. So basically you can say the address of this Matthew node will be stored inside this, right? Again, Bob has two child, so there will be a vector and it will have two child, okay, this one and this one. So basically this node Bob will have a vector and it will have the address of the node Alex and node Asha. So these nodes are depicting the person, and Catherine will have a, you can say, vector of children, and it will have no children, okay. So it will have like null basically in its vector of children, okay. So you saw there will be node, okay, and each node will have person name, okay, like Ashok, Andy, Bob, okay. And then there will be a vector of the children, that how many you can say the children that this node, okay, this person is having, okay. And then there will be a third field also in each node. Can you tell me what will be the third field in each node? There will be a status field, that is, you can say, is alive, whether a node is alive or not, or you can say whether a person is alive or not, okay, because we have to take care of this status also, right, whether this person is alive or not. Because in inheritance order, if a person is, let's say, died, like we saw that Bob was died, then this person was not taken into the account of the this inheritance order. But how we will get to know? Because there will be some information stored inside this node about the status, which will be telling me about the whether it is alive or not, okay. So there will be like is alive field, okay. So in this way I can store all the information which is given to me, okay. And whenever there is a need of the get inheritance order, how I will be taking that inheritance order? from this stored tree data structure. As we saw in the previous slide, that this will be the order of inheritance for this question. Okay, so till this point there will be order of inheritance. Basically Ashok, Andy, Matthew, and Bob will also be there. Okay, but after Bob has died, then this Bob will not be there. This will be the order of inheritance. So if you saw, first Ashok came. Okay, if we are talking just about this part, first Ashok came. Okay, then Andy, then Matthew. Okay, then there is nothing, we return. Okay, we come here. Okay, then we go to the next node. Okay, then again depth of that node. Okay, if let's say this person has child also, then we again go to this. Okay, again if it has, let's say, 2 child, we'll go there, then again to this node. Okay, and so on. Let's say we return to LX, again we come here, then again to this node. Okay, so if you see that this traversal of this tree is basically depicting which traversal. We have normally 3 traversal of the tree. Okay, pre-order, in-order, and post-order. So which traversal is this get inheritance order is depicting? How we are getting? Basically this is pre-order traversal. Pre-order traversal of this node will give me the order of inheritance. Okay, and let's say this person died. Okay, then what I will be doing, I will be just changing this is alive status to you can say death, or you can say let's say this is true or false. We can have bool type value. So I will say okay, true or false I can accordingly set, and then when I will be coming to this node, I will be just saying if it is like death, that is true or false accordingly. Okay, and I will be like taking this node, or I will be ignoring this node, but I will be just doing the pre-order traversal. Okay, so I hope you have got the idea that how I can like use the tree data structure. Okay, so let's move to the second approach. In the second approach, I will be using map data structure along with the tree. Okay, so tree, as we have discussed in the previous slide, I will be using. Okay, and along with this tree, I will be creating a map. Okay, in the map, what I will be storing, I will be storing the you can say the node name. Okay, the person name, and where that what is the address of that node. Okay, so basically the node is, let's say, Ashok. Okay, and the address is 500. Same way, the address of the Andy is 100, and address of the node containing Bob is 700. Address of the node containing Catherine, it is 800, and so on. So this node, this basically map, I will be keeping track, and how it will be like helping me with comparison to the first approach. So we have to see the what is the flaw in the first approach. So this approach one will give me the correct answer. Okay, but it will give me the TLE if I submit this in LeetCode. Okay, so why time limit exceed? Because there will be a problem with the time complexity. Basically time will be going whenever I am calling this birth and the death API. Okay, so whenever there is a birth, I will be adding a new node to the this existing tree, right? And whenever there is a death, I have to set the status of the particular node to the you can say death. By this approach, it will take a lot of time. Here I will be just giving you the hint, but I'll tell you with the help of the code in the subsequent slide. Okay, so basically what will happen when the first node come, Ashok. Okay, or you can say Ashok was the king. Okay, when this birth came, okay, what I will be doing, I will be checking from starting from the root. Okay, you can consider this as the root. Starting from the root, that where I have to add this Andy. So I will be going to the Ashok. Okay, Ashok is the parent. Okay, I have got the parent, so I will add that Andy to the you can say to the as the child of that node. Okay, so I will be adding the Andy. Okay, now when this next birth came, okay, I will saying okay, Bob is the child, and who is the parent? Ashok. So I will be searching the Ashok. Okay, so I will be searching Ashok. Okay, here in the first time I got the Ashok. Okay, so I add Bob. Okay, here also I got the Ashok. I just added the Catherine. So there is no as such time complexity related problem here, because I got the parent in the first time. Okay, but here if you see, now I have to search for the Andy. Andy is the parent, and Matthew I have to add. So what I will do, starting from the root, I will check whether it is Andy. No. Whether this is Andy. Yes. So I found the parent. Now add this particular node. Okay. Now let's assume that after this birth came, that is Matthew is the parent and Y is the child. So what I have to do, I have to again start searching from the root, that where is the Matthew. Then only I can add the Y, okay, to this Matthew. So I will to search whether this is Matthew. Okay, no. So I have to go here, whether this is Matthew. No. Whether this is Matthew. Yes. So I will create a node for the Y, and then I will add. Same way, if another birth came, Y is the parent, and let's say Z is the child. So I have to search again starting. again from the starting I have to start the search. Okay, so here search, then again search this, and then search this. Okay, I have got the parent. Now add Z. Okay, so again and again I am starting from the you can say root node to search for the parent, and then only I am adding. Okay, so this searching is taking time. Again, to set the status of a particular node as died, again I have to search that node. Okay, so let's say I have to set the status of this LX to death. Okay, is alive equal to let's say death. Then what I have to do, I have to start from the you can say root, and I have to search this entire tree where this LX is there. I have to search like Ashok, then Andy, then Matthew. Okay, then again I will come, then Bob. Okay, then Alex. Then I have found. So whenever there is a death API getting called, again and again I have to start from the root. Okay, so this is the time taking operation, birth and the death, which is actually making it a bad approach. Okay, so let's see in the second approach how we can like solve this basically searching related problem. Now in the second approach, I can get the address of the parent node, or you can say in general a node in O1 time. Let's say it is an unordered map. Okay, so let's say if I want to check the address of this Bob. Okay, so I will not be starting from the Ashok. Okay, then I will come to Andrew, then Matthew, and then backtrack and so on. Then I will come to Bob. No, nothing. I will not be doing. For searching, I will be taking care of taking the use of the map. I will be just directly coming to the Bob in O1 time. Okay, and I will be getting this 700. Okay, then accordingly I can proceed. So for the birth and that API, that searching related work, I have like removed. I will be just taking the help of the map. Okay, and that time is reduced now to the O1 time. So earlier for the searching, it was taking the O1. Okay, if n is the number of nodes at the current point of time in the tree. Now in his third approach, I will be altogether removing the tree data structure. I will be just taking the help of the map data structure, and to keep track of the dead people, I will be keeping track of the set. I will be taking the help of the set data structure. How I will be like using these data structure and how they will be help me, you will be getting better understanding when I will explain you the code for the approach 1 and approach 2. Okay, so let's see to the code. Okay, so this is the approach number 1. Okay, so here we have been given only one class, that is thrown inheritance, in our LeetCode question. Okay, and this is the default code. This is at the backend getting called. Okay, you can say this is the client code or the main. Okay, so basically we have the thrown inheritance object. Okay, and that thrown inheritance object, via that we are calling this birth API in the that API. Okay, and finally whenever we need this inheritance order, we are calling that inheritance order. Okay, so for example, okay, we have the this object thrown inheritance. Okay, and then this is the name of the king. Okay, here I have just given the name of the king as king only. Okay, and then this is the birth. Okay, this is the parent, this is the child, parent, child. Okay, there can be many birth API. Okay, like here we are giving many birth. Okay, then we are calling get inheritance. Then again after some time we say okay, someone is dying. Okay, then again we want get inheritance order. Okay, so this is the backend part. Okay, so we have the this thrown inheritance class basically given. Okay, if you see the LeetCode part, we are just given this thrown inheritance. Okay, and we are not given this. Okay, and we are given this and this, 4 basically APIs. Okay, and we have to design this question. Okay, now I'm assuming for this question that you know the tree data structure and how the classes and the structure actually works. Okay, so based on this assumption, I'm solving this question. Okay, so just to give you an overview that how this object construction and all will be happening. Okay, so here from the main we will be calling the constructor thrown inheritance. Okay, and we will be passing some name. Okay, so here let's say we are passing the name of the king as king only. Okay, so we will come to this API basically, and here there will be some code. What it will be doing in the thrown inheritance, we have a member root. Okay, root, and root is of type what, node. So basically we have taken another class node, which will be depicting or representing each of the node in the tree data structure. Okay, and in this node we will be having 3 fields. One is name. Okay, or you can say name of the person that we will be storing. Then the you can say vector of the children. Okay, and children is also like a node type. Okay, then we have taken node star. Okay, so we will be storing the address of the children in each of the node. Okay, and then there will be a status variable, that is alive, whether that node is alive or not. That will be a bool type. Okay, so you can say this is one node. Okay, and this is basically thrown inheritance object. Okay, this type. So this thrown inheritance, which will be like created. Okay, so thrown inheritance will be created and root will be there. Okay, inside this code there will be some code. I will tell you thrown root equal to new thrown inheritance. Okay, and I'll show you that this king name will be passed here like that. Okay, so what it will be doing, it will be creating a node. Okay, it will be creating a node. Okay, and the name of the node will be the like king is alive will be true, and children will be set accordingly. Okay, and then the address of that node will be stored inside this root. Okay, so root will be storing the address of this node. Okay, and here what will be happening, this particular, you can say, this object is created, and this obj will be like pointer of type this. Okay, and so this will be storing the address of this. Okay, so the root node basically it has, let's say, address 0x100, so obj will have 0x100. Okay, this is the like basic object oriented philosophy, like how this will be working. Okay, so I will not explaining each and everything again in the subsequent slide. You will be better understanding this. Okay, now let's go to the code. So as I have explained, from the main function, we will be calling this thrown inheritance constructor, and whatever the name of the king, let's say Ashok, we have passed as the name of the king. So that Ashok will be passed. Okay, and a node will be constructed. So a node, this node is constructed with name Ashok. Okay, so here you can see in the class node, we have a node constructor, right? So we will be having the setting the name of the king. Okay, name equal to Ashok. Okay, and is alive equal to true, because this node is alive. Whenever there is a birth of a person, that node basically will be set to true, and then children will by default will be like null. Okay, there will be nothing in that. Okay, currently. Okay, so this is how this thrown inheritance and this node constructor is basically working. So this is the birth API and its supporting APIs. Okay, so this birth API will be like in the thrown inheritance class, and this add child and this search, it will be defined in the node class. Okay, so in the birth API, what we will be doing, we, as I have told you in the previous slides, that in the birth we will be always searching for first for the parent. Whenever we get the address of the parent, then we will be like adding this given child to that particular parent. Okay, so we will be first what we will be doing, we will just be creating a node for the child. Okay, and then after that we will start the journey of searching for the parent, and then whenever we got the address of the parent node, we will be adding the child. Okay, adding the child to that node. Okay, so here you can see that we are first creating a node, okay, for the child. So here, let's say this is the example, Ashok is the parent and is the child with its status of alive as true, and child will be like, you can say, null. Okay, and then I'll start searching for the parent. Okay, search is defined inside the node. Okay, because I have to search in the node. Okay, so a root arrow search and parent name. Okay, Ashok will be passed. So I will be searching each and every node to search for the Ashok name. Okay, so starting from the root node, I will be searching Ashok I have found. Okay, so I will be returning this address to the, you can say, this parent node. Okay, so here now I will be calling add child. Okay, that to this parent please add the child. Okay, so to this Ashok, this parent node, please add the child. So add child will be called, and now we will be coming here. Now in this add child API, here you can see I am passing the node star. Okay, so it should be node star. Okay, now this line is not needed. Basically I have created the node here only, okay, for the child, so I need not to create any new node again here. Okay, now you can create the node here also, or you can create the node here also. So it is up to you how you are designing your APIs and how you are implementing them. Okay, so here I have got the node star, that is child node star. Okay, so I am adding that node star, that is basically ND. Okay, ND star, basically the address of the ND. Okay, this address of the ND in children node, children. Okay, so here I will be adding this address. Let's say it is 0x600, so 600 will be added. So this way the pointer will be added in the children vector of the this parent node, Ashok node. Okay, and then we will be returning. Okay, if again the birth is called, okay, let's say again the birth is called with some other name, let's say ND Matthew. Okay, then what we will be doing here, ND and Matthew is being passed. So first we will be creating node for the Matthew. Okay, and then we will be searching the this ND. Okay, we'll be searching the this ND. Okay, so here if you see the code of the search, so this is the typical search in the you can say tree data structure, how we will do. Okay, so in the search we are passing this name of the parent, that is ND. Okay, so this given name is the name that we are finding, and this name is the the name which is present in my current node. Okay, so I will be saying okay, this name, that is this Ashok is equal to my ND. I will say no. So what I will do, I will come to the children. I will check whether it's children. Okay, I will search for the vector of the children, and I will be going depth wise. Okay, so this is like the DFS way. DFS way I will be searching. Okay, so the searching this again given name ND. Okay, I will be searching. So this is basically recursion. Okay, and whenever node is not equal to null pointer, basically whenever I am able to search a particular this given name, okay, then I will be returning that node. And when this searching of this child array, it is okay, it is done, and I will be returning the null pointer. Okay, I hope this is the basic tree data structure searching. This you can implement by yourself. I need not to explain it in more detail. So basically this is depth first search type searching. Okay, depth first traversal. Now how we can implement the that API? So basically whenever we are calling the that, okay, so in the that API we are giving the name of the person who is going to die. Okay, so Bob, let's say, is passed. Okay, we have to set the status of the Bob as false. False means that person has died. Okay, so currently everything is true, okay, in each of the node as the current status. So first what I will be doing, I will be searching for this string Bob. Okay, or I will be searching for the node having the name Bob. Okay, so this is a typical search. Okay, so when I got the Bob, okay, after searching, okay, Ashok and the Matthew, that first traversal via the search API. Okay, then here I will get the address of the Bob. Okay, so this node, let's say, has address 0x100, so that node will be, that address will be returned via the search API. And when I got the address of the Bob, then I will be changing the status of that node, okay, which contains the Bob. Okay, and what status I have to set? False. False means that a particular node will be died. Okay, so I am calling the change status API in the node class. Okay, so here I will be passing the false, and that status will be passed as to the this is alive. Okay, so this is alive will be set to the false. Okay, to get the inheritance order, what we are doing, so this API will be actually returning the vector. Okay, vector of the basically names of the people who will be coming into the get inheritance API. Okay. Now as I told you that this get inheritance order is just the pre-order traversal of the tree. So you will be starting from the this basically the root node, and this will be the first person who will be coming into your list. Okay, so Ashok will come, okay, then Andy, then Matthew, and so on, as you see. So here I have taken this empty vector answer, okay, where I will be basically storing the answer. Okay, answer, okay, inheritance order. So I am calling the pre-order traversal API, which I have defined in the node. Okay, and here I am saying if the node is alive, okay, if the person is alive, then I am taking that person, okay, and then I am iterating that the children, okay, in the pre-order traversal. If that person is not alive, if the person in the node is not alive, then I am skipping it, but I will be continuing with the children of that API. Okay. So this is the typical pre-order traversal, okay, in the recursive manner. Okay, so here the first time what will happen, here is alive of the this Ashok will be checked. Okay, and I am assuming that Bob is basically died. Okay, Bob is basically false. Okay, everything other is true. Okay, so first I will come to here is alive in the Ashok node. I will be checking it is true, so I will be taking the Ashok. Okay, I am writing just in the short form, and then I will be iterating the children. Okay, so basically children means the children vector of the Ashok. Okay, so first children will come as ND, second children is Bob, Catherine is the third child. So how I am keeping tracking of the age of the children also. So in the vector, the first this ND will come, then Bob will come, then Catherine will come, right? So first is ND, then Bob, then Catherine, right? So this vector will maintain the way in which I have inserted the this child. So in this way I will be able to maintain the that who is the eldest person, then who is the next person, then who is the next person. So age order is maintained in this way, right? So the next person from here, it will be this ND, right? ND. So here what I will be doing, okay, via the address of this I will be calling this pre-order traversal again. I will be checking whether the status of the ND is alive, so I will be taking the ND, okay, and so on. And next way I will be checking the you can say the children vector of which node, ND, because the current node is ND. So I will be checking the children vector of the ND. So now, who is the eldest person in the ND list? It is Matthew. Okay, so Matthew will come in this child. Okay, and then for the Matthew, I will be calling this pre-ordered reversal. Matthew is also live. I will be taking Matthew, and so on. Okay, after everything is done, I will be like after everything is done, then answer, this is passed by reference. It will be storing every answer of, you can say, basically the list, and I will be returning that list. Now in the second approach, as I have discussed earlier, we will be using the map, okay, along with the tree. Okay, map, why we are using? So that we can reduce the time complexity of the searching. We will not be using the searching API. Okay, we will not be using this API, and now we can take the help of the map to find out the address of the parent node. Okay, and this search was also doing the same thing, that it was returning me the node address node of the parent. Okay, same thing I can do this with the help of map. Okay, so let's see how. So just to recall, map is tracking what? Map is tracking that the name of the node and the address of the node. Okay, so now our thrown inheritance object will look like this. It will have root, okay, this root pointer which is pointed to the node, and we have node details map. Okay, whenever there is a new entry in the node details map, it will be updated here. Okay, so I will not be drawing this again and again. So let's see now how this constructor is working. So whenever there is a call for the first time for the thrown inheritance, so this root will be initialized with the new node. Okay, so let's say Ashok is passed as the king name, so Ashok will be passed. Okay, accordingly Ashok T and this child array will be like initialized. Initially it will be null. The address of this particular node is initialized in this thrown inheritance object, that is inside the root, and in the map. Okay, in the map the address of this node Ashok will be stored. Okay, so I will be creating a different node, basically map here. Okay, so here there will be a string Ashok. Okay, and what is the address of the node which is containing the Ashok? That is this. So address is, let's say, 0x500. So basically 0x500 will be stored, and 0x500 is basically a root. Okay, so that's why I'm storing the root. Okay, so whenever next time if someone is searching for the node containing the Ashok, so the address will be 500. Address will be 500. Now let's see the birth API. In the birth API, this is the syntax. We will be passing the parent and we will be passing the child. Okay, parent and the child. So previously what we were doing, we were creating the child node. Okay, so for example, for Ashok comma Bob, we will be creating the child node, that is Bob. Okay, and then we were basically searching for the parent. Okay, so parent of the, basically you can say, this Ashok. We are searching where the Ashok is there, so that we can add this Bob. Okay, so we will be using the search. Okay, and then we were calling this add child to add the Bob to the Ashok. Now here what we will be doing, we will be doing the same thing. We will first creating this Bob. Okay, same as previous. Now this step and this step is added and this is removed. Now in this birth we will be adding the address of this Bob node, so that later on whenever someone wants the address of this Bob node, we can easily find. So in the previous example, when Ashok was created, we added its address. Now the address of the node Bob, okay, this Bob, basically this is string mapping to the address 700 was added, that is address, right? Okay, now after this is like for future purpose. Okay, now we will be needing the this address of the Ashok node, that is parent. Okay, previously search was giving me that address. Now from the map I will be taking that, right? So node details, the name of the map is node details, right? Node details parent name, this is the key value, and key value is basically Ashok. So where is the Ashok? This is the key. So what is the address? 500. So this is the value. So value 500 will be returned. So 500 is the address of the node which contain Ashok. So 500. Okay, so 500 is returned. Now via that address node, okay, we are calling the add child. So this add child API will be same as previous. What it will be doing, it will be adding this child, that is the Bob. Okay, we are not passing the string, we are basically passing the node star child. Okay, basically this 700. Okay, this will be passed to the add child, and what it will be doing, it will be adding that 700 here as previous. Okay, there is no change in the implementation of the add child. Okay, so this Bob is linked here. Okay, accordingly this birth API will be working. Okay, so this is the addition, this is the addition, and this is the deletion. Now we will be not calling starting from the Ashok. We are directly getting the address of the Bob in the O1 type. And let's say Bob is passed, okay, in the death. Okay, death. Okay, so we have to change the status of the Bob to false, right? Bob to false. So previously what we were doing, we were searching starting from the Ashok, we were searching for the Bob. Where is Bob? Where is Bob? Okay, in the death first traversal. So it was taking a lot of time. We were using the search API. Okay, now we are not using the search API, we are directly using the map. Okay, basically with the map we will be getting the address of the Bob. Okay, so here you can see we will be passing the Bob and it will be directly giving me in the O1 time the address of the Bob node. So we will be getting the address of the Bob node, and via that we are passing we are calling the change status. Okay, and with the false value, boolean value false, we will be changing the address basically the status as false. Okay, so just via this map we are reducing the time complexity. We are not searching from the starting. And the get inheritance order, it will be same implementation as previous we have checked. Okay, we will be just going to this tree, and we will be going into the pre-order traversal, and we will be printing the get inheritance order, that is the order of the inheritance. So in this third approach, we will not be using this tree to store the information of the parent and the child. We will be using a map, and map will be like this, that key will be the parent, and in the value field there will be the vector of the children. Okay, this parent is having. Okay, so Ashok is the parent. Okay, and Andy, Bob, Catherine was the child, so they are in the value field. Same way Andy have Matthew as the child, and Bob has the Alexa and Asha as the child. Okay, you can also write here like Matthew, Alex, and Asha, and there will be no child. Okay, the implementation will take care of that thing. Okay, if some node has no child. Okay, now how we will be keeping the track of the dead person? In the earlier tree implementation, we will be having the is alive field, right? We was having. Now how we were taking care of this set. Now how we were taking care of the dead person in the previous implementation, we were having the is alive field, right, in each of the node, right? Now here what we will be doing, we will be taking, let's say, a set. Okay, and this set will be storing the name of those peoples who have died. Now instead of the set, we can also just make use of the map only to keep track of the dead person. How? We will be taking map of this type. Basically this will be the like key. Okay, and in the value field we will be having the you can say vector of children as previous, but we will be having a pair basically. So here we will be like having the one field as the whether the person is alive or not. Okay, for example Ashok. Okay, this person is alive or not. If it is yes, then we will be keeping true. Okay, and comma this Andy, Bob, Catherine, this vector. Okay, so this whole will be treated as the value for the corresponding this key. Okay, same way let's say Bob has died. Okay, after some time Bob has died. So what we will be doing, we will be like having this field true comma and this Alex and Asa. Okay, earlier. Now when it is died, we will be just changing this to false. Okay, so this way also you can keep track of the dead person, or you can just take a separate set also. So let's say if you are implementing in this manner via this map, you can have like here the Matthew, Alex, the sleep node also, and by default their status will be like false. Okay, so it depends on the implementation how you are implementing. Okay, so here we will not be having any another class other than the throat inheritance. We will be only having this class. Okay, node class we have now removed. Okay, and this is the like APIs. Okay, same API as we were using the previous. Okay, so let's see the some implementation of this. So basically in this implementation we will be only having one object, right? Throne inheritance. Okay, and inside the throne inheritance we will be having the name of the king that we can basically set. Okay, right, and then we will be having a map. Okay, this p to child, parent to child. Okay, I'm just writing pc, parent to child map. Okay, and like something like that, and then there will be a set. Okay, set of the dead people. Okay, so how we will be starting, whenever for the first time this throne inheritance constructor will be called with the name of the, you can say, king, let's say Ashok. So Ashok will be set to here. Okay, so king is set to the Ashok, and then what we will be doing, this line is basically optional, because like it depends on the implementation. Okay, if we do not write this line also, then also our program will work. Okay, so here it is just saying okay, in the map what you will do, like for this Ashok, basically Ashok, you just say, set the array of the children as null only. Okay, empty only. Okay, if you need, okay, you can do this way, or otherwise also this map will take care of this thing also. If there is no child for a particular parent, then it's okay, you can just remove this line also. Okay, now next time, let's say whenever there is a call for the birth API. Okay, so let's say this API is called Ashok comma ND. Okay, so Ashok is passed and here ND is passed. Okay, so what I will be doing, I will be just adding the entry into the map only. Okay, nothing else. Okay, so here in the map you just add the entry of the child, okay, corresponding to the parent. Okay, so in the map I will directly go to the parent. Okay, that is the Ashok. Okay, so and in that array, or so in that vector of the Ashok, you just add this child. Okay, so as in the C++, if that particular key is not there and we are trying to push, it will automatically create that key. Okay, so in this map what we will be doing, we will be saying Ashok, and in the Ashok array, related array of the children, but it will be adding the ND. Okay, so in this map it is added. Now next time, let's say this Ashok comma Bob came, so again Ashok will be checked Ashok. Okay, we directly come to the Ashok, and comma this Bob is added. Okay, the same way Catherine will be added, right? Next time when ND comma Matthew came, so we will be coming here and parent name is ND, but ND is not there, so C++ implementation will do it by themselves. It will be creating this ND and it will be adding this Matthew as the child. Okay, so in the this object, this king is Ashok. It is depicting that who is the like master king. Okay, so this Ashok is the master king, basically the starting king. Okay, here you will be thinking that why we are using this set, like right. So we will be using the set only when there is a call to this death API. Okay, otherwise we will not be using, because in this set we will be only storing the name of the dead people only. Okay, not the alive people. Okay, so whatever name are in the dead people set, they will be like dead people. Otherwise remaining people will be considered as alive only. Okay, so during the birth API we will not be using this set. Okay, so now let's say after some time what happens, some person is called and with the death. Okay, so let's say Bob was also here. Okay, and let's say it has some children or not. Okay, we don't care, and let's say the call for the death came. Okay, so Bob. Okay, now we will be adding, we will be just adding that into the set. Okay, we will be adding into the set. So in dead people list, or you can say set, we will be adding Bob. Okay, next time let's say some other person died. Okay, let's say ND died, so we'll be adding ND into the set. Okay, this way. And at last, how this pre-order traversal will work, it will again be the same way. Okay, it will be again working in the same way, but now it will be not searching in the, you can say in your tree. Okay, it will be searching in your basically map. Okay, so as previous, it will be checking if a person is alive, then only you have to add in your answer. Okay, get inheritance order. Okay, so if dead people dot count name equal to 0 means that the person is alive, basically in that in this set. Okay, if the person is not there, okay, if the count is equal to 0, that means that person is not there, that means that person is alive. If that person is alive, you add in your answer list. Okay, and after that you just iterate, or you can say you go to the you can say the child vector of that particular parent. Okay, and one by one you try to apply the DFS. Okay, so first it will go to ND, then it will recursively go to the ND, then go to Matthew, then go to Matthew, and so on. And in the backtracking phase, then you will come to the Bob, and so on. So this is the typical traversal in the, like, you can say map, or if you understand the graph data structure also, then this is like a adjacency list basically. Okay, I hope you have got the idea of all the three approaches. The GitHub link of this code implementation will be provided in the link below. If you have any doubt or any of the comment suggestion, please write down into the comment box. Please like, share, and subscribe this channel, and please share this video among your friends so that it is helpful for them. See you in the next video. Till then, goodbye.